Hello everybody, this is Mr. Yen, and in this video I'm going to be guiding you through lesson 8.3b, titled Proving Quadrilaterals. First, let's review two of the types of quadrilaterals that we've learned. The first is a parallelogram, and that's going to be a quadrilateral with opposite parallel sides. So that means that this left side is going to be parallel to this right side. This top side is going to be parallel to this bottom side. Those are the pairs of opposite sides. And these little arrows show that they're parallel. A rhombus, that is a quadrilateral with 4 congruent sides. All of the sides are the same length. And that's shown in the diagram here. Each of these marks has the same type of hash mark through it so that they're all congruent. We've also learned that two lines such as A, B, and C, D, if they have the same slope, then we can say that AB, that line is parallel to CD. This little symbol means parallel. So I really want you to connect in your minds slope and parallel. Same slope means the lines are parallel, they'll never touch. Now, if AB and CD, if those two lines have the same length, then we know that the line AB is congruent to the line CD. Congruent, same length. So also in your minds, I want you to connect same length means congruent. Whereas if they have the same slope, that means that they're parallel. All right, with that in mind, in today's problems, you're going to be given a quadrilateral like the one you see here. And then you're going to be asked, is it a parallelogram? And then also, is it a rhombus? And you're going to have to provide evidence for why or why not. It's helpful to first figure out as much information as we can about the sides of the quadrilateral. We're going to figure out all of its slopes, and then we're going to figure out all of the lengths of the sides. So let's talk about slopes first. So the slope of AB, that's here. Well, you can see that from A to B, it's going up 1 and across 1, 2, 3, 4, 5, 6. So that's a slope of 1/6. Rise of 1, run of 6. You can also look at the difference between the two x values, going from an x of 4, from an x of -2. The difference between those two numbers is 6. Okay. Next, slope of BC. So BC, that's this side right here. I can draw on a slope triangle if that's helpful. So change in x is 2, change in y is 1, 2, 3, 4. So it's a slope of 4/2. That can be simplified by dividing both numbers by 2. So a slope of 2/1. I know it's a positive slope because looking from left to right, it's going uphill. Next is the slope of CD. That's this line here. Going from left to right, we're going up 1 and across 1, 2, 3, 4, 5, 6 units. So rise of 1, a run of 6. Next, the slope of AD. That's this side here. Looking from left to right, we're going a rise of 1, 2, 3, 4, and a run of 1, 2. So that would be 4 over 2. That simplifies to 2 over 1. Okay, we have the slopes. Now let's figure out the lengths of each of these sides. Well, the length of AB, I can use my slope triangle because I know it's 6 units this way and 1 unit that way. So if I use the Pythagorean Theorem, where C is the hypotenuse, I know that C squared is equal to 6 squared plus 1 squared. Hypotenuse squared is equal to leg squared plus leg squared. So C squared is equal to 6 squared is 6 times 6, so that's 36 plus 1 squared, which is 1. C squared equals 37. So if I took the square root of both sides to undo this squaring, I would know that AB is equal to the square root of 37. That's the length of this side here. For today's activity, you can leave your answers in exact form. You can leave it in square root form. You don't have to simplify this square root or estimate the square root. Okay, next, length of B to C. Well, I know from my slope triangle that this length is 2 and this length is 4. And I'm going to use the numbers from the unsimplified slope, remember, right? I'm not going to use 2 and 1. I'm going to use the 4 and 2. Because if you use 2 and 1, you're shortening the slope triangle. So Pythagorean theorem again, I'm going to say hypotenuse squared is equal to 4 squared plus 2 squared. So C squared is equal to 4 squared is 16 plus 2 squared is 4. So C squared is equal to 20. So if I took the square root of both sides, I would know that the length of BC is equal to the square root of 20. Okay, 2 more lengths to find. Length of CD, that's this top side. I know my slope triangle has legs of 6 and 1. It's going to be the same as AB, so I don't need to show all of my work. I can just say that CD is equal to the square root of 37. And the same thing for AD. I can see it's the same type of slope triangle that I'm using over here with legs 2 and 4. So it would be this same equation up here. So I can say the length of AD is equal to the square root of 20. I don't have to show all of the work again. Okay. Now, let's check. Is ABCD a parallelogram? Well, first it helps to think, what is the definition? The definition of a parallelogram is a quadrilateral with opposite parallel sides. So now I know to prove that this is a parallelogram, I need to prove that the opposite sides are parallel. Here's how I can do that. I'm going to use slopes, right? Remember in our minds we connected parallel, same slope. All right, so let's put our evidence together. I know that slope of AB, it's this here, is equal to the slope of CD. Therefore, and this is the mathematical symbol for therefore, it's these 3 little dots. If you're using the computer, I've left that symbol for you right here. You can copy and paste that. And if you're doing it by hand, go ahead and use that symbol for therefore. It saves you some time. Therefore, I know that side AB is parallel to side CD, right? Because I've proven that the slopes are the same. I can also say that these 2 sides, side BC with that slope and side AD with this slope, right? These are these opposite sides. Those are parallel. So I can say the slope of AD is equal to the slope of BC, and therefore AD is parallel to BC. So what I'm doing here is I'm providing evidence that shows how I know that the opposite sides of this figure are parallel because their slopes are the same. So and then in my conclusion, I can say that ABCD is, I'll circle, is a parallelogram because opposite sides are spelled like that, parallel. And notice that that's the same thing as my definition of a parallelogram. Okay, next. Well, we know it's a parallelogram. Is it a rhombus? Well, the definition of a rhombus is a quadrilateral with 4 congruent sides. Now in this case, if I wanted to prove that the 4 sides are all congruent, I would have to prove that the lengths of the 4 sides are all the same. But notice that if I just took these 2 sides, for example, length of AB, that's square root of 37, length of BC, that's square root of 20. So already I can see just by looking at these 2 sides that not all of the sides are going to be the same length. So that's what I need to say in my evidence here. I can say something like the length of AB is not equal to the length of BC, for example. And if those lengths are not the same, I can also say, therefore, and I want in your evidence, I want you to have therefore statements every time. Therefore, AB is not congruent to the side BC. So I can conclude that ABCD is not, I'm going to circle is not a rhombus because all sides are not congruent. That's what we said was the definition. Okay. So just a couple reminders. In your conclusion, always go back to your definition. That's what you're trying to prove or not prove. With your evidence, state your reasons, and then your therefores, what you can conclude from that piece of evidence. Right, and with that, you're going to do something similar for pages 2, 3, and 4. And I will say goodbye and good luck.